Okay, let's unpack this. Imagine an AI that doesn't just process data, but truly remembers like we do. Not just, a static storage unit, but with different types of memory working together, evolving, learning.
Right.
What if, that could actually lead to something like wisdom in a machine?
Well, that's exactly where we're headed today.
Yeah, we're diving deep into a fascinating new frontier in artificial intelligence, this concept of layered memory in a framework called Sophimatics.
That's right. Sophimatics, the name itself, sort of hinting at Sophia or wisdom, it's a comprehensive framework. Researchers Gerardo Iovine and Giovanni Avaner are exploring it right now.
Okay.
And our mission, really, for this deep dive is to understand how this new memory architecture might just revolutionize how AI learns, adapts, even explains itself.
Leading to what they actually call computational wisdom.
It's exactly computational wisdom.
Get ready for some serious aha moments, because we're talking about AI becoming truly context-aware and maybe even capable of reflecting on its own actions.
It's a big step.
So let's start with the core problem this whole approach is trying to solve.
Okay.
When we think about classic machine learning models, they're incredibly powerful, but their memory often works more like a static filing cabinet, right?
Yeah, that's a good analogy. It holds data, sure, but it doesn't really grasp the context, like when was this filed or how does it connect to past experiences.
Exactly.
And that static nature, well, it's a significant hurdle for AI, especially when the world around it is constantly changing.
Right.
Sophatics tackles this head on. It introduces context-aware reasoning through these distinct dynamic memory spaces. It effectively gives AI a more human-like ability to remember.
So how does it do that? You mentioned layers.
Yes, 3 distinct layers at its heart: episodic, semantic, and intentional memory.
Okay, let's peel back that first layer then. Episodic memory. If my brain has a diary for experiences, is this kind of the AI's version?
That's a perfect way to think about it. This layer stores specific observations, yeah, but critically, it also tags them with timestamps and labels. So it's not just I saw X, but I saw X on Tuesday at 3 p.m. in this specific situation.
That when and where that sounds crucial.
Oh, absolutely vital. It helps the AI recognize subtle shifts or even, abrupt changes in its data over time.
Like?
Well, think about a retail AI. Maybe it sees a sudden, unexplained drop in sales.
Okay.
With episodic memory, it could potentially connect that drop to maybe a specific, unusual ad campaign it ran last week, or perhaps a major news event that happened on that specific day.
Got it. So it's not just reacting blindly to the new data, it can actually put it in context.
Precisely. And the research points to some pretty clever techniques they're using here.
Like what?
Well, one is feature hashing. It's essentially a smart way to take all these incredibly complex, diverse categorical variables. Like, think of all the different ways people might describe a product and efficiently squash them down into a compact numerical form. Makes them easier for the AI to process.
Okay. Manage the complexity.
Right. And then there's kernel density estimation. This helps the AI basically map out the density or distribution of information in really complex, high-dimensional data sets.
Like a heat map of its knowledge.
Yeah, kind of like a constantly updated heat map of its knowledge. It lets it track how that distribution changes over time. And, recent work highlights how both these techniques really boost how effectively the AI remembers and processes this contextual stuff.
Yeah.
Significantly.
That sounds like a real shift. Okay, so if episodic memory gives the AI its raw experiences, with all their unique context, how does it organize that? How does it turn it into stable, usable knowledge?
Good question. And that's exactly where the second layer, semantic memory, comes in.
Okay.
So if episodic is the personal diary, semantic memory is more like the AI's meticulously organized library of facts and general knowledge.
A library.
It uses things called ontologies and knowledge graphs. These store information in a structured, stabilized way. Makes it easy to retrieve and apply across lots of different situations.
Knowledge graphs. I've heard of those. They sound interesting. Like networks of facts.
Yeah, basically. Networks of interconnected facts, concepts, relationships. It lets the AI not just store data, but understand how different pieces of information relate to each other.
So it can infer connections it hasn't explicitly seen?
Exactly. It's a bit like having a map of all its knowledge, letting it navigate and infer things.
And the ontologies, what role do they play?
Well, the ontologies provide the standardized definitions and relationships for those concepts in the knowledge graph.
Like the rulebook for the map.
Sort of, yeah. And this is critical because it helps the AI do things like polysemy disambiguation.
Which is?
Figuring out if a word like bank means a river bank or a financial institution based on the context.
Right, okay. That's important.
Very. It also handles synonym resolution, recognizing that car and automobile mean the same thing. This allows the AI to interpret new data correctly and keep its knowledge base updated dynamically.
And this knowledge isn't static either then. It can be updated.
Absolutely. These ontological frameworks are designed to be easily updated, so the learned knowledge stays dynamic and adaptable. It's all supported by what they call a hybrid symbolic connectionist system.
Okay, break that down. Hybrid.
Yeah, think of it as a clever blend. You get the logical, rule-based reasoning of traditional AI, the symbolic part, and you combine it with modern deep learning's ability to recognize patterns from data, that the connectionist part.
So best of both worlds.
Kind of aiming for that, yeah. It allows for both stable knowledge representation and flexible, context-appropriate application, even when things are changing fast.
And this layer talks to the other.
Oh, definitely. The semantic layer is intricately linked with episodic and, as we'll see, intentional layers.
Right.
This interconnectedness gives it flexibility, especially when dealing with data that's uncertain or incomplete, which, let's face it, is most real-world data.
Makes sense. Okay, that brings us neatly to the third layer. Intentional memory. Now, this is where things get really intriguing, I think. Because this layer stores information about the AI model's explicit goals, its purpose, its rationale.
Yes, its underlying rationale. It moves AI beyond just what it does to why it does it.
And the crucial benefit there seems to be transparency, cooperation.
Both, really. It's about ensuring genuine transparency and fostering real cooperation in human-AI partnerships. Imagine an AI that can literally tell you its goals and purposes.
Okay, wow.
It can infer its own intentions, logically state the outcomes it's aiming for. That's vital if you want effective cooperative planning with human partners.
That's a huge capability. How does it work? How can it infer intention?
Well, one approach involves something like inverse reinforcement learning with logical reward specifications.
Okay, that sounds complex.
It is a bit, but the core idea is this. Instead of just being told what to do, the AI observes our actions, or maybe optimal actions, and tries to figure out the underlying goals or values, the why.
So it learns our goals by watching.
Essentially, yes. And it uses logical rules to make sure its own actions then align with those inferred goals. This allows the AI to actually inform us about its intentions, clarify why it's doing something specific. It makes its actions understandable.
So this layer is really about clarifying the system's goals, making the whole process, intentions, planning, outcomes, transparent.
Exactly. But it's also about more than just transparency. It's about translating all that memory content from episodic and semantic into proper actions and choices.
And adapting those actions if the goals change.
Precisely. Adapting its behavior as its purposes are updated. And critically, it maintains those open communication channels with the other two memory layers. That allows it to fully support expressing its reasoning.
So it raises that question. What does it mean when an AI can actually tell you why it's doing something?
And perhaps more importantly, what kind of collaborative future does that really enable?
Right. Okay, so we have these three layers. Episodic, the diary, semantic, the library, and intentional, the goal setter. But here's where it gets really interesting, you said.
Yes, the integration. The true power isn't just in the layers themselves, it's how they work recursively together.
Recursively, meaning they influence each other constantly.
Constantly. This interconnectedness forms the very basis for true context-dependent reasoning in Sophimatics-based AI. And this is a really significant departure from, say, standard deep learning, which often struggles with that kind of recursive interaction or genuinely reflective actions.
Can you give an example of that interaction?
Sure, think of it like this. A new experience gets logged in episodic memory. Maybe a surprising outcome from an action the AI took.
Okay.
That new experience can immediately impact the semantic layer. The AI might update its generalized knowledge, its facts, based on that surprise.
Right, okay, that didn't work as expected, so maybe my understanding is flawed.
Exactly. And that updated knowledge in the semantic layer could then, in turn, affect the goals or priorities stated in the intentional memory layer.
Prompting it to maybe rethink its whole approach.
Precisely. It's a powerful feedback loop.
That structure ensures knowledge isn't just stored, it's actively updated through continuous interaction and, crucially, reflection.
Yes. And by adopting both, how we know things, epistemology, and how we reason logic, Sophimatics seems to overcome some key limitations of previous AI approaches. It supports much richer context-aware processing and decision-making.
So for you, the listener, what does this all really boil down to?
Well, it means an AI that can genuinely learn and grow. By integrating all this memory-based information and context, the AI can reflect on its actions, it can justify them, and it can significantly enhance its reasoning performance over time.
So this layered memory architecture, it's not just about better recall.
No, not at all. It's about a fundamentally more sophisticated form of intelligence.
It improves that context-sensitive retrieval we talked about.
Yes.
Gives the AI the capability of intentionally storing and, importantly, flexibly adapting its goals.
Right. Adapting is key.
It enables reflective actions and, crucially, the clear explanation of why it took those actions.
And the overall integration of all three layers enhances the AI not just in memorizing and recalling knowledge from different perspectives and contexts.
But also in justifying, reinterpreting, and evaluating its own actions.
Exactly. And the researchers argue that incorporating these architectural design elements permits AI to reach an advanced level, one that truly enables it to gain this computational wisdom.
Wow. So, stepping back, what does this all mean for the future of AI? This deep dive into layered memory and Sophimatics? It really paints a vivid picture, doesn't it?
It really does.
AI moving beyond just crunching data to truly understanding and reasoning within dynamic, real-world contexts.
Yeah, remembering the when and where of experiences, organizing vast amounts of stable yet flexible knowledge.
And even stating its own goals, explaining its choices. This framework pushes us closer to AI systems that can reflect, adapt, and operate with a much higher level of, well, comprehension.
It's a profound shift, really, moving from static models to potentially truly dynamic, intelligent entities.
Imagine the possibilities for human-AI collaboration. When your AI partner can actually explain its reasoning, adapt its goals when things change, learn from experiences in such a nuanced way.
It changes the dynamic completely. This pursuit of computational wisdom, it isn't just a technical upgrade. It feels like a journey towards a fundamentally different kind of artificial intelligence.
Which leads to a final thought. What might an AI truly capable of computational wisdom decide to do first?
That's a good question.
Something to mull over until our next deep dive.